Alright, we're going to read Chapter 4 and then we're going to look at the Chapter 4 figures. Modification use 1500 kilowatt engine set with the dual fuel operation. Describe the series systems of the existing components with connected with electrical circuitry, electrical conduities, and any other mechanical links to actual modification hardware procedures described in reference 4.14243 has been assembled. The ECI incorporated based on AV prototype application stationary power use of publication essential proper installation. The dual fuel kit with the section draws heavily on with a supplement with the information specified with an AV use and units. The description each system includes the schematic detail drawings, photographs for the installation process, engine modifications. The power pack assembly, the dual fuel power pack assembly shown on the figure 4.1 and include with the head modified with the receiver, the gas injection valve, the dual of the fuel position, top surface of the head been modified with a lower compression ratio of the 14.5 to 12.8 provided with a greater intensity mix of natural gas, air, and natural gas connecting hardware include with the load valve with the load block, gas air lines, gas inlet valve. Although the head pistons are chained with the ring sets are specially parts of the head, the power pack assembly perceived identical to the standard diesel power pack figures 4.2a through 4.2d with the trill of the placement with the gas inlet valve with the cylinder head with attachment with the natural gas supply with the control air hoses. 412 cylinder relief valve, the ECI with the cylinder pressure relief valve, the figure 4.3 used of the replace with the standard cycle of testing, the cylinder test valve, the valves are located each cylinder just under the natural gas supply line, receiving the excess pressure for the areas during gas operation. 413, the diesel fuel supply, original dual fuel system is modified with the provide pilot fuel capability during natural gas operations. Standard diesel injection is required with a special calibration provided with the correct pilot fuel quantities. Modification include with addition of the pilot fuel stop assembly mounted with the injector rack with the control linkage system with the air rams. Pilot stops actually with the control air pressure with the solenoid valve control with the engine control unit during higher loads. Left hand ram is extended with the load drops to below 20% of the second ram and energized with an increase of the pilot fuel with a stabilized combustion light load. Figure 4.4 show the elements of pilot fuel stop. Similarly modified injector control ring rack linkage. Figure 4.5 show photographs of the engine modification components. 4.2 natural gas supply system. Figure 4.6 shows schematic diagram showing the insulation gas lines of the engine housing leading to the engine cylinder external gas, natural gas supply with the control components leaving the engine housing. Figure 4.8 shows the photograph of the natural gas piping fittings and their insulation. Under normal aspiration, natural gas is used in the units of pressures 100 to 150 psi, but the pressure normally must be reduced to the higher supply pressure closely regulated with the desired level of the gas fed. First passes of the master manual shut-off valve followed by the pressure regulated with the passes of the two-area operated shut-off valve with the piping tube with the blades for the pressure relief valve set as a 150 psi filter and air-operated vent valve onto the natural gas pipe in the interior of the engine housing. These passes with the instrument running with a figure 4.9 gas temperature pressure flow rate with a measure of the third air-actuated gas cup valve, the gas flow control valve. The engine control unit determines the time of the gas operation valve 1, valve 2, and gas control cutoff valve are open briefly with a period of 5 seconds to with the natural gas supply with the deployment of the V1 and V2 with a clove with the pressure and natural gas in line of the downstream them and the monitoring at 180 seconds. Should the pressure remains constant and no significant leaks are present in the gas supply line, a pressure less than 3 psi must be observed for the system to pass the test. Gas line does not pass integrity test vented into the atmospheric pressure through the vent valve located with the gas flow control valve. Figure 4 turn on the exterior vent pipe V1 and V2 of the remain closed. Engine is prevented with the proceed with the natural gas operation. The gas line passes the integrity test of the valves of 1 and 2. Open proceed with the natural gas supply with the gas control cutout valve. At point of the ECU can open with the gas control cutout valve. Starts at the sequentially on the gas inlet valves. Each cylinder provided with the flow of the natural gas to the item glow gas flow rate with the engine is controlled with the gas flow control valve, the positions of which are determined the determined mechanical linkage output shaft, the Woodward governor, steering diesel components governor engine speed, load and load. From the gas flow control valve, the gas makes it through the headers to each load block with the gas inlet valve, the load block restrictor valve with adjusted to increase the pressure, increase or decrease gas flow with each cylinder balance power with the delivery of the gas pressure is header. Control with the gas flow control valve, change the load average over to 25 to 65 psi. Switching diesel operation, gas cutout valve with V1 and 2 are closed. Gas inlet valve cease to operate shortly, therefore leaving the natural gas in the header. Gas is immediately vented to the V with the vent valves and the gas control valve and the natural gas supply live into the unit. No natural gas lines within engine skid remain pressurized at any time to accept the engine is operating on it. Alright, 4.3. Control your air system. Most working parts of the conversion pneumatically actuated require the reliable flow of the compressed air. The largest single requirement of the compressed air with the actuation of the gas inlet valve requires a 17 cubic feet SCFM, large compressor 30 SCFM versus the original 15 CFM. Similarly sized air storage tank of 200 SCF at 275. Installed with a Muse unit with the compressor installation described in section 4.5. Air from the compressor must pass through the filter, regulator, and air lubricated figure 4.12.13. One branch of the airline then passes directly from the gas inlet valve, figure 14 and 4.14, 4.15, with a pictorial air hose connect with the detailed routing of the air to the gas inlet valves. Item 2 with the figure 4.14 show the second air supply going into the air supply cabinet of the air control houses in the issue annuate and emanate, providing actuating the air with the diesel ram. Item 3 with the pilot fuel stop. Item 4 with the vent valve on the gas control valve. Item 5 and gas cutout valves 6 and 7. Items 8 through 11 indicate additional air hoses routes to the left of the install with the terminal location components connected by the air fixed. Detail of the air supply tubing of the gas inlet valve shown figure 4.16. The air internal arrangement of the air supply cabinet is shown figure 4.17. The schematic diagram for the mounting bracket of the ESC and electronic supply cabinet, emission supply cabinet, and air control cabinet. Figure 4.18 photographs of the mounting with figure 4.19. Air throttle 4.4. Air throttle is a device used for the control of the amount of the air combustion air available to the engine, provided with the means of the operating of the engine, increase the efficiency with the reduce the loads located with the turbocharger inlet. Figure 4.20 compared with the original turbocharger installation with the insulation that included the air throttle. Figure 4.21 provides photograph modified insulation. Figure 4.5 engine cooling system. Engine cooling system has been enhanced by adding cooling water circuited to some of the parts of the cooled water stream existing with the rated directly inlet with the aftercooler. Figure 4.22 with the provide with the greater cooling of the combustion air with the normally obtained with the allow with the operation engine of the natural gas mode with the increase of the power level of the added water with the circuit with the required with the use of the aftercooled water pump with the further enhancing cooling of the combustion air with the ECI design 6-pass aftercooler to replace the standard 2-pass aftercooler of the new aftercooler. Figure 4.23 designed for the counterflow accomplished. Both sides of the engine coolers are installed with the following guidelines for the AMD maintenance manual. The standard aftercooler is 440 gallon per minute. Used aftercooling circuit installation of the new cooling water pump along with the new air compressor is shown figure 4.24 with the 4.27. Original air compressor air tank has been replaced with one greater capacity of the structural strength of the place mount. Water pump also has to be found with the mounting plate capable of supporting both in the design figure 424A through 424B. So as original air compressor mounting configuration filling one of both the air compressor and the water pump installed. Figure 425 shows the support platform supported with a forced position by compressed air tank of the 2-channel air and leg supports mounted by the side of the I-beam of the units and a force support leg. Figure 426, 427 provide specifications for the compressed air tank and platform and supported legs and platform. 4.6 sensors. Sensors are provided with a variety of measurements. Figure 428, important that they operate properly. Out of specification measurement of warning signs indicate that either the engine malfunction or properly function sensing. In either case, they may indicate the dangerous hazard condition caused by the engine. The temporary operation. Figure 429, 430 show installation of several of the sensors described below. Thermocouples are fitted to one per cylinder of the engine manifold. They are used to monitor the temperature of the exhaust gas coming from each cylinder. Primary indication proper cylinder performance. Water temperature badly partial fail. The sensor would display the engine control unit as an error. Control air pressure provided with a compressor at 200-240 psi is reduced and pressure with the pressures to regulate with a control range at 125 to 135 psi. Pressures more than 4 psi outside of the range cause an unit to shut down. Flywheel sensor apparatus consists of 3 sensors mounted with a bracket over the flywheel along with the sensor target with the 2 sensors provided with the timing information of the engine control unit with the position sensor with a 1/4 inch targets embedded into the flywheel with their output with a synchronized natural gas sequencer with a camshaft for the timing injection of natural gas into the cylinder. 3rd sensor is positioned directly over the teeth of the ring gear with the gear teeth as targets to determine flywheel speed. Airbox temperature is monitored to sense temperatures that become higher than 200 degrees Fahrenheit, where they lead to the engine knock when operating natural gas mode. Airbox pressure indicated with the turbocharger function low. Airbox pressure is less than 14 psi indicated with the turbocharger is probably being directly driven directly by the engine. High pressure greater than 17 psi indicates sufficient exhaust gas at higher engine loads to cause the turbocharger to disengage with the engine to be driven solely by the exhaust gas to later result with the most efficient engine operation. Natural gas and sensors include the temperature pressure sensor for the delta pressure sensor for the delta pressure transducer for the motor condition over the natural gas upstream of the gas flow control valve before admitted to the gas header along with the flow rate to the engine. Gas header pressure measures for the pressure of the natural gas at the end of the header for to supply with a minimum level that must be maintained with the continue the engine operates except for the pressure indicate the gas engine malfunction. Alright, 4.7, natural gas safety system. Several approaches used to ensure the safe natural gas operation use units include both hardware additional modification operational chain with the natural gas consists mostly of methane, colorless, odorless, non-toxic gas. Familiar with the odor of gas often smell with not of that methane, but small amounts of sulfur containing compounds added specifically to provide pungent odor. This is a safety feature provided all natural gas supply with the odor is not noticeable the varying smell concentrations. The main concern of the natural gas when mixed with a concentration between 5 and 15% of the natural gas by volume for the form of the combustible mixture. The mixture that should be formed in the space that would be subject to explosion confronted by an adequate ignition source has a 110-volt electrical circuits. Many circuits with less voltage provide ignition source sufficient to initiate with a natural gas explosion. Many of the source circuits exist with use engine enclosure approach of the taking with ensure the safety environment has to make it ensure that the natural gas concentration engine space will never reach the level of the explosive concentration. This is involved in ensuring the adequate ventilation of the engine speed along with the insulation operation gas detection system. The fact that natural gas is lighter than air and the stronger tendency to rise away with the source of any leak helpful of achieving this approach. Appendix A include the analysis of the recommended design modification for operational procedure to ensure the safety of the operation fuel conversion study with an undertaking for the fair safety consult with a particular expertise for the handling of the natural gas for the enclosed area with the recommendation study with the incorporated with the design operation characteristics fuel conversion. Figure 431 shows the cutaway side view. The use unit indicated with the natural gas piping routing. Safety features include with the pipes running of the figure 432 with the planning view of the showing with the airflows within the engine compartment to prevent the accumulation of natural gas explosive concentration ventilating rate compartment and such of the observed with the natural gas supply lane concentration of natural gas for the engine compartment would not reach explosive level assuming the exhaust blower is properly functioned. System interlock prevents entry of the natural gas engine compartment. Or E engine control engine control unit controlled unless the exhaust blower is shown as operating unless airflow gases cages show adequate ventilation actually taking place unless the natural gas detection system shows absent any measurable concentration of explosive gas. The shutdown level is at 10% of the lower explosive limit for natural gas. This allows the presence of some of the hydrocarbon vapors, greases, and oils within the unit and provide with a conservative monitoring level of the presence of the natural gas for any leaks in the natural gas system. Figure 433 and 434 show the installation of natural gas sensor and connecting conduits and wiring. Alright, 4.8 electrical system control. Pictorial view. The main feature of the electrical control system shown in figure 435 of the two main electrical control cabinets for the engine control unit of the air service cabinet and the analog termination box is shown with a basic wiring scheme. The system is indicated in figure 436, which shows 16 wire runs and 12 in which numbers 1, 3, 4, 5, 7, 10, 11, 12, 13, 14, 15, 16 are contained with conduits flexed or hard. Number 7, the type of the wires which each run are indicated. Each wire carries an alphabetic designation or design is laid out in manner with the harness assembled with the factory can be pulled with the conduits attached to the terminal strips of the conduit of the engine control unit leads with the A of the operating system status screen, B an analog termination box, and B the air supply cabinet. With the conduit leading from the engine control unit to the air supply cabinet actually contains several distinct harnesses for the gas inlet valve to control the emission of natural gas to each cylinder. Control functions existing engine control panel and switchgear housing, control harness, solenoids with the air supply cabinet, and D electrical signals of the engine control panel for actuating water pumping for the controlling and receiving signal of the gas detection system. 481 engine control unit. Engine control unit controls all the major functions of the dual fuel engine operation. Electronic device conservation should be given in the ambient temperature proposed location, prevent unnecessary overheating of the wide location. May be any place with the engine generator housing with the gathering engine operation data existing control function. Figure 437 provides a block diagram of electronic control system signals entering and leaving the engine control unit. Figure 438 shows the physical layout side of the inside of the engine control unit, wiring connections internal with the engine control unit, shown figure 439. Engine control digital inputs, analog inputs, digital outputs, gas inlet valve outputs, shown figure 440 through 443. Schematic diagrams for the switch house connection harnesses are shown figure 444 and 445. Terminal connections to the air supply cabinet and the analog termination box shown in figure 446. Additional drawings of the wire harness are shown in figure 447 through 450. 482 air service cabinet, engine control panel, internal components of the air supply cabinet, air service cabinet is described in section 4.3. Electrical wire hookups were discussed in the subpub section above. Photographs of wiring of the engine control unit, air service cabinet are shown in figure 451. Photographs of the ECP modification shown in figure 452. 483 gas inlet valve wire harness. Gas inlet valve wire harness leaves the air service cabinet with the upper deck under the valve cover, which are divided in two segments either side of the engine. Figure 453 leads to each cylinder operating the solenoids. Valves do emit natural gas monitoring temperature at each valve temperature switch. 4.9 switchgear, external power hookups, and external communication. All hardware electronically linked with a diesel generator actively located with a switchgear housing. Interconnects between the engine housing and switchgear. Figure 454 included by the three-phase 4,160 volt power carrying conductors, 40 wire umbilical internet connecting cable transmitting energy electronic control data in second. Umbilical containing 12 shielded triads at 20 gauge communication between the engine control unit and the remote site with electronic control of the natural gas sensors mounted with the engine housing by the hazard gas control module. Mounted in the switchgear housing, second umbilical includes signal wire, 5 telephone connections. 2 of these separate signals are stopping units from the remote side. 2 dedicated lines with the purpose to avoid the possibility of interrupted telephone service interfering with the control of the unit. 3 of the other lines are transmitting operated data remote site control center. 2 of the other off-base site modem interconnects between the switchgear housing and the base side of the power carrying cables containing 4-inch underground continuity. Telephone interconnecting cable carried 1-inch underground continuity. Electrical wire connections to and within switchgear housing are described in schematic drawings referred to in section 410. Photograph switchgear installations are shown in figure 455. 410 modification of MUSE schematic drawings. The impact of modification discussed above with the MUSE schematic drawings have been incorporated with the drawings indicated with appendix B's. Modified drawings have been identified with the designated dual fuel appended to original drawing numbers. And then we'll go over the drawings actually. Okay. So we'll do part 4 drawings in the separate video.